Hello my dear student, hope you all are well. Welcome to Amader Pathshala. Today I am here just to take a class of higher math in intermediate section. You just see that class 11 and 12 subject higher math. First paper, our today's topic is straight line. First paper chapter 3. Okay. Then learning outcomes. At the end of our lesson, the dear student, you all will be able to know first of all define straight line and discuss concept of straight line. Second one, explain the concept of Cartesian and polar coordinates in the plane. Third one, establish and apply the relation between Cartesian and polar coordinates. Okay. Then find the formula of the distance between 2 points. Then determine the coordinates of the point which divides a line segment internally or externally a certain ratio. Discuss mathematical problems. Okay. At first we are going to learn straight line. A straight line is a line traced by a point on a coordinate plane traveling by a point on coordinate plane in a constant direction, that is the locus of a point without changing any direction is a straight line. Okay. Then French mathematician René Descartes and Pierre de Fermat first applied algebraic formula in geometry and thus made the basis of the coordinate geometry. Coordinate geometry is one of the most important part and existing ideas of mathematics which provides a connection between algebra and geometry through graphs of lines and curves. Okay. Then we are going to discuss relation between polar coordinates and Cartesian coordinates with the help of a diagram. You just see that let x o x dash and y o y dash be x axis and y axis where O is the origin. Let the coordinate of the point P let the Cartesian coordinate of the point P be x comma y and that of polar coordinates be r theta. Okay. Then you just see that from the point P we draw a perpendicular PM on OX, and if we join O comma P, then OP is the radius vector, and by the concept of coordinate geometry OM equals to x and PM equals to y. This is abscissa and this is ordinate. So PM is perpendicular, OM is base and OP is hypotenuse, since POM is a right angle triangle. So by the formula of trigonometric ratio we get that cos theta is equal to base by hypotenuse, that is abscissa of the point P and radius vector. Abscissa of point P is x and radius vector is r. So x by r is equal to cos theta. By cross multiplication we get that x is equal to r cos theta. This is the relation number 1. Similarly, the trigonometric ratio of sine, that is sine theta equals to perpendicular by hypotenuse, that is ordinate of P by radius vector. Ordinate of P is y and radius vector is r. So by cross multiplication as before y is equal to r sin theta. This is the relation number 2. Now you just see that squaring 1 and 2 then adding we get that x square plus y square is equal to r square sin square theta, r square sin square theta plus cos square. In the right hand side if we take common r square, then we will get r square into sin square theta. Since sin square theta plus cos square theta equals to 1 according to the formula of trigonometric, so r square is equal to x square plus y square, that is r is equal to square root of x square plus y square. If x is not equals to 0, then dividing by 2 by 1 we get that y by x is equal to sin theta by cos theta. We know that sin theta by cos theta is tan theta, so tan theta equals to y by x. If we take tan theta from the left to the right, then it will be inverse. So theta equals to tan inverse y by x. Okay. Then now we would like to see the values of theta in different quadrants as follows. First one, in the first quadrant where 0 less than theta less than pi by 2, in the first quadrant 0 less than theta less than pi by 2 for the point x comma y, theta equals to tan inverse absolute value of y by x. Second one, in the second quadrant where theta lies in the second quadrant, pi by 2 less than theta less than pi. For the point minus x comma y, theta equals to tan inverse y by minus x. We can rewrite this one, pi minus tan inverse absolute value of y by x. Third one, in the third quadrant, it means that pi less than theta less than 3 pi by 2. For the point minus x comma minus y, theta equals to tan inverse minus y by minus x. If we rewrite this, then by the coordinate then we can write down pi plus tan inverse y by x. Fourth one, in the fourth quadrant, pi by 3 pi by 2 less than theta less than 2 pi for the point x comma minus 1, then theta equals to tan inverse minus y by x, that is it will be 2 pi minus tan inverse absolute value of y by x. The above four relations are applied to convert the Cartesian coordinates into polar coordinate. Okay. Then now we are going to discuss distance formula. We mean that we are going to find the distance between the 2 points. Now we are going to discuss distance formula with the help of a diagram. You just see that let x o x dash and y o y dash be x axis and y axis, where y is the origin. Okay. Let the coordinates of the point P and Q be x1 and y1 and x2 y2 respectively. We draw two perpendiculars PM and QN on OX respectively. Then another perpendicular QR is drawn to PM. Okay. You just see that. So by the concept of coordinates, we can OM equals to x1, ON equals to x, so MN equals to x1 minus x2. Again, you just see that Q1, QN is y2, so Rn is also y2, Rm is also y2. Again, PM is y1, so PR equals to y1 minus y2. Again, you just see that distance. Then by the Pythagoras theorem, we can, in right angle triangle PQR, what is Pythagoras theorem? In the opposite side of the right angle, square of the opposite side of the right angle is the sum of the square of the other two sides. So we can write down PQ square equals to QR square plus PR square. You just see that we have written like this. Okay, PQ equals to square root of QR plus PR. Now if we put the value of QR and PR, we get PQ equals to square root of x1 minus x2 whole square plus y1 minus y2 whole square, which is the required distance between 2 points Px1 y1 and Qx2 y2. Okay. This is the distance formula between the 2 points x1 y1 and x2 y2. Okay. Now we are going to see a mathematical problem. I mean question 1. If the Cartesian coordinates of any point is -1 comma root 3, then find the polar coordinates of that point. Let -1 comma root 3 equals to x comma y. Since these two ordered pairs are equal, so x equals to -1 and y equals to root 3. If the polar coordinates of the point be r theta, then we know that r is equal to square root of x square plus y square. Now if we put the value of x and y, then we will get that square root of -1 whole square plus root 3 whole square. -1 whole square, it means that this is 1. Root 3 whole square, it is 3. 3 plus 1, this is 4. Square root of 4, this is the 2. So radius vector is always positive. That's why you have written plus 2. Okay. Then tan theta equals to, it's a formula, tan theta equals to y by x. The value of y is root 3, the value of x is -1, so it will be minus root 3. This minus is here. Tan of 60 degree equals to root 3, so minus tan 60 degree. By then we can rewrite this tan according to the quadrant concept. Tan of, in the second quadrant tan is negative, that's why you have written tan 180 degree minus theta. Theta is 60 degree. Tan of 180 degree minus 60 degree, that is tan 120 degree. Ultimately it will stand like this, tan theta equals to tan 120 degree. It means that therefore theta equals to 120 degree. I mean, if we omit tan, the ratio tan from the both sides, then we will get theta equals to 120. So the required polar coordinates is 2, 120 degree. This is the answer. Okay, then next one. We are going to see the another problem. If the polar coordinates of any point is 3, 90 degree, then find the Cartesian coordinates of the point. Let 3, 90 degree. It's a polar coordinate. That's why you have written the let 3, 90 degree equals to r, theta. Since these two ordered pairs are equal, so r equals to 3 and theta equals to 90 degree. If the Cartesian coordinates of the point be x, y, then you can write down x is equal to r cos theta and y is equal to r sin theta. If we put the value of r and theta in these two relations, then we get x is equal to 3 cos 90 degree equals to, since the value of cos 90 is 0, so it will be 3 into 0, that is 0, and y is equal to r sin theta, that is 3 sin 90 degree equals to 3 into 1 equals to 3. Hence the required relation is x, y, that is 0, 3. This is the answer, completed. Next one. Now we are going to see another mathematical problem. I mean question 3. Express the Cartesian equation x square plus y square minus 2ax equals to 0 into polar equation. You just see that. We know that. We have already learned r square is equal to x square plus y square, where x is equal to r cos theta and y is equal to r sin theta. Given that x square plus y square is equal to 2ax, that's why you have written x square plus y square, its value is r square. 2a, this 2a, and x, the value of x is r cos theta. Okay, that's why you have written within the third bracket putting the above values. If we divide both sides by r, then we get r is equal to r. If we divide r square by r, that is this is r. If we divide 2a r cos theta by r, then we will get 2a cos theta. That's why we have written in the within the third bracket dividing both sides by r, which is the required polar equation. This is the answer. Now we are going to see another problem. I mean question 4, convert the polar equation r is equal to 2a cos theta into the Cartesian coordinate. Again, we know that r square is equal to x square plus y square, where x is equal to r cos theta and y is equal to r sin theta. This is the relation number 1. Given that r is equal to 2a cos theta. Now we are multiplying both sides by r, then we get r square is equal to 2a r cos theta. Okay, we know that the value of r square is x square plus y square. You just see that x square plus y square, then this 2a is here and r cos theta, its value is x. So x square plus y square is equal to 2x. If we take 2ax from the right hand side to left hand side, it will be minus. Ultimately it will be x square plus y square minus 2x equals to 0, which is the required Cartesian equation. Okay, then question number 5. This is the formula of distance formula. If the distances of the point 5, k from x-axis and from the point minus 5, minus 7 are equal, then find the value of k. Let p be the point. Now we are discussing this problem with the help of a diagram. Let p be a point 5, k and n be a point minus 5, minus 7. You just see that. And the distance of the point 5, k from x-axis is just the k. That's why we have written here absolute value of k. The distance must be positive. That's why we have used the absolute value, I mean modulus. Okay, then and that of between the points minus 5, minus 7 and 5, k, I mean the distance between the points minus 5, minus 7 and 5, k. The distance we have already learned. The distance formula was square root of x1 minus x2 whole square plus y1 minus y2 whole square. Here this is x1, this is y1, this is x2 and this is y2. So it will be square root of minus 5 whole square plus minus 7 minus k whole square minus 5 whole square. It means that minus 10 whole square of minus 10, this is 100. Okay, then minus 7 minus k. We are going to expand this with the help of a minus b whole square. A minus b whole square, its expansion is a square minus 2a square plus 2ab plus b square. So minus 7 whole square, this is 49 plus 2 into minus 7 into minus k, it will be 14k plus minus k whole square, this is k square. Okay, now we are square root of this k square plus 14k. If we add 100 plus 49, it will be 49. These two distances are equal. That's why you are going to write down by the condition square root of k square plus 14k plus 149 equals to absolute value of k. If we square both sides, then we will get a square k square plus 14k plus 149 equals to k square. Absolute value of k square means k square. Okay. Then if we omit from the k square from the both sides, then we will get 14k plus 149 equals to 0. Okay. Therefore, k equals to minus 149 by 14. We cannot express the 149 and by 14 into the lowest form. Then so it will be the answer. Okay. Next one. Now we are going to discuss section formula. I mean internal section formula and external section formula. At first we are going to discuss internal section formula with the help of the diagram. Okay. Let us suppose that the point C xy divides the line joining the points a x1 y1 and b x2 y2 internally in the ratio m1 is to m2. We are going to find the coordinates of the point C. You just see that here AC by CB equals to m1 is to m1 by m2. Okay. Then we draw perpendicular. We draw the three perpendicular AP, BQ and CR from BC on OX respectively. Then another two perpendicular AS and CT are has been drawn on CR and BQ. Okay. Then you just see that here OP equals to x1, AP equals to y1, OQ equals to x2, BQ equals to y2, OR equals to x and CR is equal to y. That's why it will be PR equals to x minus x1. Since PR is equal to x minus x1, so AS is equal to x minus x1. So again RQ equals to x1 minus x, so CT equals to x1 minus x. Again you just see that similarly it will be BT equals to y2 minus y1. Okay. You just see that the triangle ACS, this triangle ACS and this triangle CBT or BCT are similar. Why similar? These two triangles are equiangular. All equiangular triangles are similar. That's why the corresponding sides of these two triangles, the ratio of the corresponding sides of these ratio of the sides of these two triangles must be equal. That's why you have written here AS by CT equals to CS by BT equals to AC by CB equals to M1 by M2. From the relation AS by CT equals to M1 by M2, if we put the value of AS and CT, then by making calculation we get the value of x equals to m1 x2 plus m2 x1 by m1 plus m2. Again you just see that if we write down CS by BT equals to m1 by m2, and if we put the value of CS and BT, then we get that and by making calculation y equals to m1 y2 and m2 y1 by m1 plus m2. This is the internal section formula. You just see that there is a note: if the line joining the 2 points x1 and y1 and x2 y2 internally divided in the ratio m1 is to m2, then the coordinates of the section point, or we call it dividing point or split point, is m1 x2 plus m2 x1 by m1 plus m2, then m1 y2 plus m2 y1 by m1 plus m2. Okay. Then there is a special note. You just see that if m1 is to m2 equals to 1 is to 1, it means that if C divides the line AB into two equal parts, that is if C is the middle point or midpoint of the line AB, then the coordinates of the point C is x1 plus x2 by 2 and y1 plus y2 by 2. Since the value of m1 is 1 and value of m2 is 1, that's why m1 plus m2 equals to 2. ultimately it will be stand x1 plus x2 by 2 and y1 plus y2 by 2. Okay. Then now we are going to discuss similarly if we discuss the external formula with the help of a diagram, then we get that if the line joining 2 points p x1 y1 q x2 y2 is externally divided m1 is to m2 at the point r, then the coordinates of the section point or dividing point or split point is m1 x2 minus m2 x1 by m1 minus m2, then m1 y2 minus m2 y1 by m1 minus m2, which is shown is in the adjoining figure. Okay. Then now we are going to discuss a question number 5. Find the coordinates of the point that divides the line segment joining the points p minus 1, 1 minus 1 and q 8, 6 internally in the ratio 3:4. Let the points be r x y that divides the line segment joining the points p 1, minus 1 and q 8, 6 internally in the ratio 3:4. You just take a look in the figure. Here PR by QR equals to 3 by 4, that is 3:4. Then x is equal to, we have already learned the formula, m1 x2 plus m2 x1 plus by m1 plus m2. So m1 is 3 and x2 is 8, you just see that, plus m2 is 4 plus into x1 is 1. So by 3 plus 4. If we make calculation of this part, then we will get 28 by 7. Ultimately its result will be 4. Then y equals to m1 y2 plus m2 y1 by m1 plus m2. So it will be 3 into 6 plus 4 into minus 1 by 3 plus 4. Then by making calculation we will get 14 by 7. So 14 by 7, it means that it will be 2. So the required point is 4, 2. This is the answer. Now we are going to see another formula, another problem. It's an example of external section formula. Find the coordinates of the point that divides the line segment joining the points p 3,4 and q 5,7 externally in the ratio of 3:5. You take a look in the figure. Let the coordinates of the point be r x y that divides the line segment joining the point p 3,4 and q 5,9 externally in the ratio 3:5. Then we can write down x equals to, is the formula, m1 x2 minus m2 x1 by m1 minus m2. So it will be 3:5, 3 into 5 minus 5 into 3 by 3 minus 5. Ultimately it will be 15 minus 15 by minus 2, 15 minus 15, so 0 by minus 2, 0 by something, it is equals to 0. So y equals to m1 y2, m1 y2 minus m2 y1 by m1 minus m2. So it will be 3 into 9 minus 5 into 4 by 3 minus 2, 3 into 9, this is 27, 5 into 4, this is 20, 3 minus 5, this is minus 2. You just see that 27 minus 20, this is 7 by minus 2. Ultimately it will be minus 7 by 2. So the required coordinates of the point is x comma y. Ultimately 0 comma minus 7 by 2. This is the answer. Okay, then now we are going to discuss another mathematical problem. Question 7. If A is a point whose coordinates 2, 5, B is another point whose coordinates 5, 9, D is another point whose coordinates 6, 8 at the vertices of a rhombus A, B, C, D, then find the coordinates of the point C and the area of the rhombus. So our findings is, there are two findings. Find the coordinates of the point C and find the area of the rhombus. You just take a look in the adjoining figure. Let the coordinates of the point C be x, y. So the coordinates of the middle point of the diagonal AC. The coordinates of A is 2, 5 and the coordinates of C is x, y. So the middle point is formula is x1 plus x2 by 2 and comma y1 plus y2 by 2. So it will be x plus 2 by 2 comma y plus 5 by 2. Then that of the diagonal of diagonal BD. I mean the middle point of the BD 5 plus 6 by 2 comma 9 plus 8 by 2. Ultimately it will be 11 by 2 and 17 by 2. Since you just see that, we know that the diagonal of the rhombus bisect each other at their point of intersection. That's why the midpoints of AC and BD are same. So we can write down x plus 2 by 2 equals to 11 by 2, and if we multiply both sides by 2, then we will get x plus 2 equals to 11. Ultimately, if we make calculation of this part, then we will get x equals to 9. And then y plus 5 by 2 equals to 17 by 2. So it will be y plus 5 equals to 17 or y equals to 12. So the coordinates of the point C is 9, 12. Now we are going to find the area of the rhombus. What is the formula of the area of the rhombus? You just see that area of the rhombus of ACD equals to half into product of two diagonals, ultimately half into AC into BD. So we are going to find the value of AC and BD. You just see that BD we are find the formula with the help of distance formula, square root of x1 minus x2 whole square plus y1 minus y2 whole square. That's why it will be 5 minus 6 whole square plus 9 minus 1 8 whole square equals to square root 5 minus 6, this is minus 1 whole square equals to 1, 9 minus 8 whole square equals to 1 square means 1, so it will be square root of 2. Similarly, AC equals to square root of 2 minus 9 whole square plus 5 minus 12 whole square equals to 2 minus 9, this is minus 7, square of minus 7 equals to 49, and 5 minus 12, it is also minus 7, square of minus 7, it is also 49, so it 2 into 49, square root of this square root will be distributed to 2 and 49. So square root of 49 is 7, so it will be turned 7 root 2. The area of the rhombus ABCD equals to half into AC into BD. We have already mentioned this. Half into the value of AC is 7 root 2 and the value of BD is root 2. This is square unit. So this root 2 into root 2. This is 2. So these 2 will be vanished. Ultimately its result will be 7 unit square unit. Okay, then now we are going to discuss another problem. Show that the origin is one of point of intersection joining the points 3, minus 2 and 6, 4. Okay, you just see that. Take a look in the adjoining figure. Let P x1 y1 and Q x2 y2 be the point of trisection of the line segment joining the points A 3, minus 2 and B 6, 4. Then P and Q divides the line segment into the ratio 1:2 and 2:1 respectively due to trisection. Okay, then so the coordinates of P will be with the formula of internal section formula m1 x2 plus m2 x1 by m1 plus m2. So that's why it will be 1 into 6 plus 2 into minus 3 by 1 plus 2, and then m1 x2 plus m2 y1 by m1 plus m2 1 into 4 plus 2 into minus 4 minus 2 by 1 plus 2. So it's if we make calculation of this part, it will be 0 0. You just see that there is a homework. Two end points of a diagonal of a parallelogram minus 3, 4 and 6, minus 3. If the third point of the parallelogram is minus 2, 1, then find the coordinates of the its 4 point. Find the second one, find the polar coordinates of the point minus 1, minus 1 root 3. If the vertices of the triangle this A point and B point, find the centroid of the triangle. Thanks to all, stay safe and sound.